Section 3, Classifying Elements, page 12. Well before scientists could see the individual atoms, scientists were finding ways to study, identify, and classify atoms. If you had to organize your closet, how would you do it? One way would be to look at the color and the shape of your clothes. But how would scientists classify elements if they could not see what their different atoms looked like? In the early 1800s, a German scientist named Johann Dobryner noticed an interesting pattern with his certain elements. He observed that lithium, sodium, and potassium are all soft gray metals. He also noticed that all three elements react with water. He grouped these three elements together based on their property of reacting with water. However, they do not react in the same way. Pure lithium only fizzes when exposed to water. Pure sodium can react violently enough to create a fire when mixed with water, and pure potassium practically explodes when it gets wet. Dobryner then looked at the atomic masses of these three elements. The atomic mass is the mass of a single atom. All atoms of an element have approximately the same atomic mass. So that means 2 atoms of aluminum would each weigh about the same. Scientists report atomic mass in a unit of measurement called daltons. The atomic mass of hydrogen is 1 dalton. Oxygen's is 16 daltons. When Dobryner arranged lithium, sodium, and potassium in increasing order by atomic mass, the middle element, sodium, had an atomic mass that was almost exactly halfway between the atomic masses of the other 2 elements. He noticed that sodium's atomic mass, 23 Da, is close to that of the average of lithium's, 7 Da, and potassium's, 39 Da, or daltons. He used his observations and their atomic mass to predict that the middle element in this type of group would react and behave as an intermediate of the other 2. Section 4, the periodic table, page 13. In the mid-1800s, English scientist John Newlands continued to think about Dobryner's ideas that elements showed patterns in atomic mass. Newlands arranged all of the then known elements in order by increasing atomic mass. Once he organized them, he noticed that the elements shared similar characteristics that repeated every 8th element. Soon after, Russian scientist Dmitry Mendeleev arranged the elements into a table with 8 vertical columns. He listed them from left to right across each horizontal row of the table, such that the elements increased in atomic mass. The elements in the row below had greater atomic masses than the elements in the row just above them. Mendeleev did not just arrange the elements by atomic mass, he also grouped them into columns according to similar characteristics. Mendeleev noticed the same pattern of properties in atomic mass that Dobryner did. He knew that lithium, sodium, and potassium all have similar properties, so he placed these 3 similar elements in the same column of the table. Mendeleev knew the shared properties of each column were important. So when an element fit into the order of atomic mass but did not share the properties with its column, he left a blank space in the table. He hypothesized, which means he had a guess, like an educated guess, that the blank space in the table that he created stood for an element that had not yet been discovered. He also predicted that its properties would be similar to those of other members of that column. He even used the averages of atomic masses on either side of a missing element to predict its atomic mass. It turns out that Mendeleev's predictions were correct. In the late 1800s, scientists discovered 3 elements that matched the predicted properties of the blank spaces in Mendeleev's table: gallium, scandium, and germanium. Mendeleev had designed the first working version of an important tool. This tool would later be known as the periodic table. The periodic table of the elements is a table that lists all of the known elements and groups them into columns by important shared properties.